Okay, part 2 of our graphing with tables using these functions. Let's get into it. Learning objective for today. I can graph lines given information from tables. Vocab is all review vocab. We had that input-output table, that input-output chart from before. It's just a table that shows how input values, x's, domains, are paired with output values, ranges, the y's. Looks like this vertically, looks like this horizontally. So, example 1. We have 0, 10, 122, 234, 346. All positive values, just like our example in the other video. So I only need to use the first quadrant. And now I can start plotting some points. Remember, the first value is our horizontal. The second value is our vertical. So I'm talking 0, 10. So that would be 0 movement on the horizontal, up 10 on the vertical. 1, 22. 1 horizontally, 22 vertically. 2, 34. 2 horizontally, 34 vertically. 346, 3 to 46. And our plots are pointed. Our points are plotted. Whatever. Connect them with a line. There's example 1. You try. Take a look at this problem. 0, 40, 130, 220, 310. Set up your graph, see what you can do. Okay, so 0, 40, 130, 220, 310. It's a downward going line. Starting at 40. Example 2, using our tables, setting up our tables. I have small values, so I could plug in to find my inputs and outputs. Love using 0. Always use 0, guys. It's one of the easiest ones to use for inputs. I plug in a 0 for x. 5 times 0 makes 0. So all I'm left with is negative y equals 3. Get rid of that negative by multiplying both sides by negative 1. 3 times negative 1 makes negative 3. So there's my output. And I could plot that point at 0, then down 3 spaces for 0, negative 3. Do the same thing with other values. I like using small numbers. So if I plug in a 1, 5 times 1, subtract it, gets me negative 2. Multiply both sides by that negative. Negative times negative makes positive 2. Do that again for a third time, and I get 2 is 7. Plot these points. 0, negative 3. Okay, 0, 1, 2, 3. 1, 2. Horizontally first, then up 2. Uh-oh. 2, 7. 2, oh, we're a little too big for my graph. But if we follow that pattern, if we follow that line, it should go right through there. There's example 2. Your turn. Try again. X minus y equals 5. If you've been keeping up with the videos, I think this one's a repeat of the other day. X minus y equals 5 turns out to look something like this. Connect them together. There's our graph. One more example. Because with one of the projects we will do, you're going to start seeing different lines. Some of them aren't always diagonal, like we've seen so far before, where they're going up or they're going down at those different diagonals. Some of them, the outputs are the same, the inputs are the same. Like, take a look at this one. We've got 0, 1, 2, 3, but all of our outputs are 25. Real quick, is that a function? Yes or no? Okay, the inputs are all different, so yes, that is a function. But let's graph this thing. 0, 25, 1, 25, 2, 25, 3, 25, all at the same output. Gives me a horizontal line going straight across. Very important to remember and very interesting, in my opinion. All the same outputs gives me a completely straight horizontal line graph. One last piece of this one. This time you have y equals 5. So I want you to think, what kind of table will be set up from y equals 5? And then what kind of graph will we get from that as well? Hint, it's similar to what we just did in example 3. Okay, so hopefully you took the time to think about that one. I could plug in any x value. It won't matter because there's no place to plug in x. So the x's don't matter. The y's are always going to be that 5. That's our rule. So when I graph this thing, I'm going to have that horizontal line going straight across at 5. That's where it comes from. And that's all we've got for today, guys. Take care. We'll talk it up in class. Please let me know if you have any questions.